It is permissible to run 277 volts and 120 volt circuits within the same conduit, provided specific conditions are adhered to for safety and code compliance. Firstly, the type of conduit is critical. It must be either rigid metal conduit, known as RMC, or intermediate metal conduit, referred to as IMC. PVC conduit is not suitable for this application due to its flammability and lack of mechanical strength. Secondly, the wire rating must be considered. All conductors, including those for both the 277 volts and 120 volt circuits, must be rated for the higher voltage, which is 277 volts. Using conductors rated only for 120 volts in a 277 volt circuit creates a significant safety hazard. Thirdly, conductors in separate compartments are necessary. The 277 volts and 120 volt circuits must be physically separated within the conduit. This separation can be achieved in one of two ways: using a divider installed inside the conduit to create distinct compartments, or running the circuits in separate parallel conduits. This prevents any potential arcing or short circuits between the different voltage levels. Fourthly, proper grounding is essential. The conduit itself must be grounded in accordance with the National Electrical Code, known as NEC. Grounding ensures that any fault current has a safe path to ground, minimizing the risk of electrical shock or fire. Fifthly, segregation at termination points is crucial. The 277 volt circuits must be kept separate from the 120 volt circuits at all termination points. This includes junction boxes, switches, and light fixtures. Clear labeling and physical separation are vital to prevent accidental contact between the different voltage levels during maintenance or repairs. Additionally, special considerations arise because the 277 volt circuits are fed from a panel connected to an emergency generator. The conduit installation must comply with the NEC requirements for critical circuits. This involves enhanced protection against physical damage and the ability to withstand the heat and flames of a fire, ensuring that the emergency lighting system remains operational during an emergency. The NEC guidelines provide detailed specifications for the materials and methods used in critical circuit installations. Here's a more detailed breakdown. Firstly, conduit type. Only RMC or IMC conduit is acceptable for running both 277 volts and 120 volt circuits. RMC provides the highest level of protection against physical damage and corrosion, making it suitable for demanding environments. IMC offers a lighter weight alternative to RMC while still providing adequate protection. Secondly, wire rating. Conductors must have an insulation rating suitable for the maximum voltage present in the conduit. In this case, all conductors must be rated for at least 277 volts. Common insulation types include THHN/THWN, which are widely used for general wiring applications and are rated for 600 volts. Thirdly, separation of conductors. To prevent electrical interference and ensure safety, it is best practice to separate the 277 volts and 120 volt circuits within the conduit. This can be achieved by using a divider or barrier inside the conduit, creating distinct compartments for each voltage level. Alternatively, you can run the circuits in separate conduits, providing complete isolation between them. Fourthly, grounding requirements. Proper grounding of the conduit system is essential for safety. The conduit must be connected to a grounding electrode system such as a ground rod or a metallic water pipe, in accordance with the NEC. Grounding ensures that any fault current will safely flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Fifthly, segregation at termination points. At all termination points, such as junction boxes, switches, and fixtures, the 277 volts and 120 volts circuits must be clearly identified and physically separated. This prevents accidental contact between the different voltage levels, which could result in electrical shock or equipment damage. Sixthly, critical circuit considerations. Because the 277 volt circuits are connected to an emergency generator, they are considered critical circuits. Critical circuits must be installed in a manner that ensures their continued operation during a power outage or other emergency. This typically involves using fire-rated conduit and wiring methods and providing backup power sources. When dealing with electrical installations involving different voltage levels and emergency power systems, consulting with a qualified electrician is paramount. They can assess the specific installation requirements, ensure compliance with all applicable codes and standards, and provide expert guidance on safe and effective wiring practices. Now let's discuss more in detail about each point. Regarding conduit types, rigid metal conduit or RMC is a heavy-walled threaded tubing, typically made of steel, although aluminum versions are also available. It offers exceptional mechanical protection for conductors and is suitable for both indoor and outdoor applications. RMC is joined using threaded fittings, creating a robust and continuous metallic raceway. Intermediate metal conduit or IMC is a thinner-walled version of RMC, also made of steel. It provides similar protection to RMC but is lighter in weight and easier to work with. IMC is also joined using threaded fittings. The NEC specifies the types of conduit permitted for different applications, considering factors such as voltage levels, environmental conditions, and the presence of hazardous materials. PVC conduit, while widely used in many electrical installations, is not permitted for running both 277 volts and 120 volt circuits together, especially when one circuit is connected to an emergency generator. PVC is a non-metallic conduit offering corrosion resistance and ease of installation. However, it lacks the mechanical strength and fire resistance of metal conduits. Regarding wire rating, the insulation rating of a conductor indicates the maximum voltage it can safely withstand. Conductors are available with various insulation types, each designed for specific applications and voltage levels. Common insulation types include THHN/THWN, XHHW, and use. THHN/THWN is a widely used general-purpose insulation suitable for dry and wet locations. It has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. XHHW is a cross-linked polyethylene insulation, offering excellent moisture and heat resistance. It is suitable for both dry and wet locations and has a temperature rating of 90 degrees Celsius. Use is an underground service entrance cable, designed for direct burial applications. It has a moisture-resistant insulation and is suitable for wet locations. When running both 277 volts and 120 volt circuits in the same conduit, all conductors must have an insulation rating of at least 277 volts. This ensures that the insulation will not break down under the higher voltage, preventing short circuits and electrical hazards. Regarding separation of conductors, physically separating the 277 volts and 120 volt circuits within the conduit minimizes the risk of electrical interference and accidental contact. This can be achieved by using a divider or barrier inside the conduit. Dividers are typically made of metal or plastic and are designed to fit snugly inside the conduit, creating separate compartments for each voltage level. Alternatively, you can run the circuits in separate conduits, providing complete isolation between them. This is the preferred method when dealing with sensitive electronic equipment or in areas where electrical noise is a concern. Regarding grounding requirements, proper grounding of the conduit system is essential for safety. Grounding provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies the grounding requirements for different types of electrical systems. In general, the conduit must be connected to a grounding electrode system, such as a ground rod, a metallic water pipe, or a concrete encased electrode. The grounding conductor must be sized according to the size of the circuit conductors, as specified in the NEC Table 250.122. Regarding segregation at termination points, at all termination points such as junction boxes, switches, and fixtures, the 277 volts and 120 volts circuits must be clearly identified and physically separated. This prevents accidental contact between the different voltage levels, which could result in electrical shock or equipment damage. Labeling is crucial for identifying the voltage of each circuit. Use clear and permanent labels to indicate the voltage of each conductor and terminal. Physical separation can be achieved by using barriers or partitions inside junction boxes and enclosures. This creates distinct compartments for each voltage level, preventing accidental contact. Regarding critical circuit considerations, circuits that are essential for safety and emergency response are considered critical circuits. These circuits must be designed and installed to ensure their continued operation during a power outage or other emergency. The NEC provides specific requirements for critical circuits, including the use of fire-rated conduit and wiring methods and the provision of backup power sources. Fire-rated conduit is designed to withstand high temperatures and flames, preventing the spread of fire and protecting the conductors inside. Backup power sources, such as emergency generators or uninterruptible power supplies, provide power to critical circuits when the normal power supply is interrupted. When dealing with critical circuits, it is essential to consult with a qualified electrician to ensure compliance with all applicable codes and standards. Here are some additional considerations. Firstly, voltage drop. When running long circuits, voltage drop can become a concern. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source. This can affect the performance of equipment and can even damage it. To minimize voltage drop, use conductors that are sized appropriately for the load and the length of the circuit. The NEC provides guidance on voltage drop calculations. Secondly, harmonics. Harmonics are distortions in the electrical waveform that can be caused by nonlinear loads such as electronic devices and fluorescent lighting. Harmonics can cause overheating of equipment, increased energy consumption, and interference with other electrical systems. To mitigate harmonics, use harmonic filters or reactors. Thirdly, surge protection. Surge protection devices, known as SPD, protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed at the service entrance and at any sensitive electronic equipment. Fourthly, arc fault circuit interrupters. Arc fault circuit interrupters, called ASIs, are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. ASIs are required in many areas of the home, such as bedrooms and living rooms. The National Electrical Code serves as the cornerstone of electrical safety in the United States. It's a comprehensive set of standards that dictates the safe installation of electrical wiring and equipment. Compliance with the NEC is not just a good practice, it is often mandated by law to protect people and property from electrical hazards. Article 300.3 of the NEC addresses the requirements for conductors of different systems within the same raceway, cable, or enclosure. It generally permits conductors of different voltage systems, such as 277 volts and 120 volts, to occupy the same enclosure, provided that all conductors are insulated for the maximum voltage of any conductor within the enclosure. This means that even the 120 volts conductors must have insulation rated for 277 volts or higher. However, there are exceptions and specific requirements that must be followed. For example, if the 277 volt circuits are considered emergency circuits or a part of a legally required standby system, additional requirements may apply to ensure their reliability and separation from normal power circuits. NEC Article 700 covers emergency systems, while Article 701 addresses legally required standby systems. These articles outline specific requirements for wiring methods, overcurrent protection, and transfer equipment to ensure that these critical circuits remain operational during power outages. Another important aspect to consider is the ampacity of the conductors. Ampacity refers to the maximum amount of current a conductor can carry continuously without exceeding its temperature rating. The NEC provides ampacity tables in Article 310 that specify the ampacity of different conductor sizes and insulation types under various conditions. When running multiple conductors in the same conduit, the ampacity of each conductor must be derated to account for the increased heat generated by the proximity of the conductors. Derating factors are specified in NEC Table 310.15b3. In addition to opacity rating, it's also crucial to ensure that the conduit fill does not exceed the maximum allowable fill specified in NEC Chapter 9, Table 1. Exceeding the conduit fill can make it difficult to pull conductors, increase heat buildup, and potentially damage the insulation. The NEC also addresses grounding and bonding requirements in Article 250. Grounding ensures that non-current carrying metal parts of electrical equipment are connected to earth, providing a path for fault current to flow back to the source and trip a circuit breaker or fuse. Bonding ensures that all metal parts within an electrical system are electrically connected, minimizing voltage differences and reducing the risk of electrical shock. Proper grounding and bonding are essential for safety and are required by the NEC. Furthermore, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or ETL Semco. Listing and labeling indicate that the equipment has been tested and meets established safety standards. Using listed and labeled equipment is crucial for ensuring the safety and reliability of electrical installations. In the context of running 277 volts and 120 volt circuits in the same conduit, it's also important to consider the potential for electromagnetic interference. Electromagnetic interference, or EMI, can occur when the electromagnetic fields generated by one circuit interfere with the operation of another circuit. To minimize EMI, it's recommended to use shielded conductors or to separate the circuits as much as possible. In addition to the NEC local codes and regulations may also apply to electrical installations. It's essential to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. Electrical work can be dangerous, and it's always best to hire a qualified electrician to perform any electrical work. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with all applicable codes and regulations.